ddx of e to the power x equals to e to the power x. Here my function is e to the power x, so I will assume y as e to the power x. So let y equals to e to the power x, and let that be equation 1. Like in theorem 1, if there is an increment delta x, there will be an increment delta y. So y plus delta y can be written as e to the power x plus delta x. See here, in place of y I have written y plus delta y, so that time in place of x you have to write x plus delta x, and let that be equation 2. Now let us subtract 1 from 2, so we will have y plus delta y minus y equals to e to the power x plus delta x minus e to the power x. So here minus y plus y gets 0, and we will have delta y equals to e to the power, see, e to the power x plus delta x can be written as e to the power x into e to the power delta x minus e to the power x. So dividing both sides by delta x, we will have delta y by delta x equals to, and in numerator we will take e to the power x as common, so it will be e to the power delta x minus 1 whole divided by delta x. Okay, now I will do the limit both sides where delta x tends to 0, delta y over delta x equals to, now here in the left hand side e to the power x is like a constant, because limit is, because I am doing the limit where delta x tends to 0. Okay, so delta x you should treat as variable, and e to the power x you can treat as constant. So e to the power x will come in front of limit, so it will be e to the power x limit delta x tends to 0 e to delta x minus 1 over delta x. In previous chapter we had this formula, so if I compare this formula with this particular portion, then it is matching, so this portion will be 1. Okay, limit delta x tends to 0, delta y over delta x means dy by dx equals to e to the power x, and that limit is 1, so it will be e to the power x, and hence we will replace the value of y as the e to the power x only, because from equation 1 you can see that y was e to the power x. So here ddx of e to the power x will be equals to e to the power x, and that was the proof for this principle. So that ddx of sine x equals to cos x. Here the function is sine x, so I will write y as sine x. So let us assume y equals to sine x, and let that be equation 1, and hence y plus delta y will be equals to sine of x plus delta x. Okay, so let us subtract equation 1 from equation 2, so we will have y plus delta y minus y equals to sine of x plus delta x minus sine of x. So here y and y gets 0, so we will have delta y equals to, now we will use this formula sine a minus sine b. Okay, because this is in the form of sine a minus sine b. So here if I compare, my a will be x plus delta x and my b will be x. Okay, we will have 2 cos of a plus b by 2. This is a plus b by 2, and there is sine a minus b by 2, a minus b by 2. So clearly here minus x plus x gets cancelled, divide both sides by delta x, so we will have delta y over delta x equals to 2 cos of, here x plus x will be 2x plus delta x over 2, and here it will be sine delta x over 2, and whole divided by delta x. Okay, now let us put the limit both sides where delta x tends to 0, limit delta x tends to 0, delta y over delta x equals to 2, limit delta x tends to 0, cos of 2x plus delta x by 2, and let me write this separately. Sine delta x by 2 whole divided by del x. On the left hand side we are having dy over dx equals to 2 limit delta x tends to 0 cos of 2x plus delta x over 2 into limit delta x tends to 0 sine of delta x over 2 by delta x. Now see here, in place of this theta there is delta x by 2, so I will make this delta x as delta x by 2 by multiplying and dividing by 2 like this. Okay, and also the limit delta x tends to 0, then delta x by 2 also tends to 0. As delta x tends to 0, delta x over 2 will also tends to 0. You can divide both sides by 2. Okay, so here in next line we will have dy over dx equals to 2, and this portion let us put the limit delta x tends to 0 here, so it will be cos 2x plus 0 over 2 into limit delta x by 2 tends to 0 sine delta x by 2 whole divided by delta x by 2, and this 2 let me write in front, so it will be divided by 2. So as you can see here, this portion is 1 because we had one formula, limit x tends to 0 sine x by x is 1. Okay, so this whole portion will be 1. 2 and 2 will get cancel, so we will have dy over dx equals to cos 2x plus 0 is 2x by 2 into 1, and this implies dy by dx equals to 2 and 2 will simplify to 1, so it will be simply cos x only. And since our function was sine x, so ddx of, in place of y, let me write sine x, so ddx of sine x equals to cos x. So this is the proof for this theorem. Next we have to show ddx of cos x equals to minus sine x. Let y equals to cos x, and that be equation 1. Therefore y plus delta y will be equals to cos of x plus delta x, and let that be equation 2. So subtract 2 minus 1, so we will have y plus delta y minus y equals to cos of x plus delta x minus cos x. So here in the left hand side y and y gets 0, so we will have delta y equals to, here in this form we have cos a minus cos b. Okay, so we will use this formula here. So here a means this portion and b means x. Okay, so now let us use that formula. So it will be minus 2 sine of a plus b by 2, that is a plus b by 2, and sine a minus b by 2, that is a minus b by 2. So here x and x are getting cancelled. Let me divide both sides by delta x also. So it will be delta x equals to minus 2 sine, see x plus x will be 2x here, plus delta x by 2 sine delta x by 2 whole divided by delta x. I will write this portion together and this portion separately. Okay, so let me limit both sides. Limit delta x tends to 0, delta y over delta x equals to minus 2 is constant, no need to write limit there. So limit delta x tends to 0 sine of 2x plus delta x by 2 into sine delta x by 2 by delta x. Okay, so this will implies dy over dx equals to minus 2. Now let me distribute this limit. Be limit delta x tends to 0 sine of 2x plus delta x over 2 into limit delta x tends to 0 sine of delta x by 2 over delta x. Now as you can see, the angle is delta x by 2, so let me make delta x by 2 here by dividing with 2 and multiplying by 2. We have dy over dx equals to minus 2. Let us put the delta x as 0 here. 2x plus 0 by 2 into, and since delta x tends to 0, obviously delta x by 2 will also tends to 0, so this particular portion will be 1 and this 2 will come in front. So let me write that 2 in front first, and that portion will be simply 1. Okay, so this implies dy by dx equals to minus 2 by 2 is simply minus 1 only, minus sine 2x by 2. Here 2 and 2 gets cancelled, so we will have dy by dx equals to minus sine x, and since our function was cos x, so in place of y let me write cos x here. So ddx of cos x equals to minus sine x, and that is the proof for this theorem. Next we have function tan x, and ddx of tan x equals to sec square x. So let y equals to tan x, therefore y plus delta y equals to tan of x plus delta x, and let that be equation 2. So subtracting equation 1 from 2, so we'll have y plus delta y minus y equals to tan of x plus delta x minus tan of x. So in the left hand side you will have y and y 0, so delta y equals to tan of x plus delta x minus tan of x. So delta y equals to, now tan theta can be written as sine theta over cos theta, so it will be sine x plus delta x over cos of x plus delta x minus tan x can be written as sine x over cos x. Okay, so let me simplify here. Delta y equals to, so now if you take the LCM, then it will be cos of x into cos of x plus delta x, and in numerator you have sine of x plus delta x into cos of x minus cos of x plus delta x into sine of x. So this will implies del y equals to, here in the numerator we have sine a cos b minus cos a sine b. This has a and this will be b, and this portion is a and this portion is b. The portion means the angle. Okay, so this is sine a cos b minus cos a sine b. Now this is the formula for sine a minus b, so the numerator will be sine a minus b. A means x plus delta x minus b means x. Okay, whole divided by cos of x into cos of x plus delta x. So here x and x are getting cancelled. So now let me divide both sides by del x now. Okay, so del y by delta x equals to sine of delta x by cos of x into cos of x plus delta x whole divided by x. Now if I divide this fraction whole divided by x, then finally it will be here only. Okay, so let us put the limit here. It will be limit delta x tends to 0 delta y over delta x equals to, now if you notice here in the denominator this cos x is acting as constant, so let me write this in front. Okay, so it will be 1 by cos x, and let me distribute the limit at the same time also. Okay, so delta x tends to 0, and let me write sine of delta x over delta x into limit delta x tends to 0 1 by cos of x plus delta x. Okay, now as you can see, this portion is 1, and here I will put the value of delta x as 0 here. Okay, so we will be having dy over dx equals to 1 by cos x into 1 into 1 by cos of x plus 0. So it will be 1 by cos x into 1 by cos x. So it will be 1 by cos square x, and since cos x is the reciprocal of sec x, so it will be sec square x. Hence d dx of tan x will be equals to sec square x, and that is the proof for this theorem. Next we have to show that d dx of sec x equals to sec x into tan x. Okay, so the function is sec x here, so let y equals to sec x, therefore y plus delta y equals to sec of x plus delta x. So, and this be equation 2. Let us subtract 1 from 2, then we will have y plus delta y minus y equals to sec of x plus delta x minus sec x. So here y and y gets cancelled, so we will have delta y equals to, now sec of x plus delta x can be written as 1 by cos x plus delta x minus sec x is 1 by cos x. So this implies delta y equals, let us take the LCM here, we'll have cos of x into cos of x plus delta x, and in numerator we will have cos of x minus cos of x plus delta x. Okay, this implies delta y equals to, now here in numerator, and this is in the form of cos of a minus cos of b. For that we have one formula, so here if you see that our a, and let this be our b, so using this formula we can write minus 2 sine of a plus b by 2 and sine of a minus, so here let me put one more bracket, x plus delta x by 2. Okay, and whole divided by cos of x into cos of x plus delta x. Delta y equals to minus 2 sine 2x plus delta x by 2 sine x minus delta x by 2. So here minus and minus will get cancelled, whole divided by cos of x into cos of x plus delta x. Now let us divide both sides by delta x, then we will have this equals to minus 2 sine 2x plus delta x by 2 sine of minus delta x by 2 whole divided by cos of x into cos of x plus delta x into del x, since we are dividing both sides by del x. Okay, so this implies del y by del x minus 2 into sine of 2x plus delta x by 2. This cos x can be treated as constant, so let me write with this 2, it will be cos x here into 1 by, let me write this cos of x plus delta x separately, so 1 by cos of x plus delta x into sine of minus delta x by 2 divided by delta x. In numerator if you see sine of minus delta x by 2, so sine of minus theta is minus sine theta, so it will be minus of sine delta x by 2, and that minus let me write in front, and that minus will multiply with this minus and it will get plus. Okay, so it will be delta y by delta x equals to 2 by cos x into sine of 2x plus del x by 2 into 1 by cos of x plus delta x into sine of delta x by 2 divided by delta x, and since here the angle is delta x by 2, so let me write the into by 2 into 2. I'll write this particular 2 here. Now let me put the limit delta x tends to 0. So we'll have limit delta x tends to 0 del y by del x equals to 2 by cos x. Let me write this particular 2 in front, it will be 2 only and 2. Now let us put the limit here. Limit delta x tends to 0 sine of 2x plus delta x by 2 into, and let us distribute the limit also. It will be limit delta x tends to 0 1 by cos of x plus delta x into limit. Now as delta x tends to 0, so delta x by 2 also tends to 0 sine del x by 2 by del x by 2. So here as you can see, this particular portion is 1. Here I will put the delta x as 0, and here also I'll put delta x as 0. So here 2 and 2 gets cancelled, and on the left hand side I am having dy over dx. So this will be equals to 1 by cos x into sine 2x plus 0 is 2x only, so 2x by 2 into 1 by cos of x into 1. So here also 2 and 2 are getting cancelled, so I'm left out with 1 by cos x can be written as sec x into sine x by cos x, and this will be equals to sec x. Sine x by cos x can be written as tan x. Therefore dx of sec x equals to sec x tan x. So this is the proof for this theorem. Next, number 7, ddx of cosec x equals to minus cosec, sorry, there is x here. So here we have ddx of cosec x equals to minus cosec x cot x. So let our function is cosec x, then y plus delta y equals to cosec of x plus delta x. So subtracting 1 from 2, you will get y plus delta y minus y equals to cosec x plus delta x minus cosec x. So here we will have delta y equals to, see, cosec is the inverse of sine, so I can write 1 by sine x plus delta x minus 1 by sine of x. This implies delta y equals to, on simplification by taking LCM, we will have sine x into sine x plus delta x, and in numerator we will have sine x minus sine of x plus delta x. Now using this formula here, we will have delta y equals to 2 cos of a plus b by 2 sine of a minus b by 2 whole divided by sine of x into sine of x plus delta x. Okay, we will further simplify. Delta y equals to 2 cos of 2x plus delta x by 2 sine of minus delta x by 2 whole divided by sine of x plus delta x. Let us divide both sides by delta x, so it will be delta y over delta x equals to, let me write this 2 by sine x in front, to sine x into cos of 2x plus delta x by 2 by sine of x plus delta x into, and here as you can see there is sine of minus theta, so sine of minus theta is minus sine theta, so let me write this minus here in front. Okay, so here it will be minus in front, so it will be sine delta x by 2, and since we were dividing both sides by delta x, so let me write delta x here, and since the angle is delta x by 2, so let me make delta x by 2 here by multiplying and dividing by 2. Okay, now as you can see this particular 2 and this particular 2 will get cancelled. Next we will put the limit delta x tends to 0, delta y over delta x equals to minus 1 by sine x, limit delta x tends to 0, cos of 2x plus delta x by 2 whole divided by sine x plus delta x. Let us distribute the limit, and since delta x tends to 0, delta x by 2 also tends to 0, so it will be sine delta x by 2 whole divided by delta x by 2. So here this portion is 1, and here we will put delta x as 0, so we will have dy over dx equals to minus 1 by sine x cos of 2x by 2 whole divided by sine of x into 1. So this implies dy over dx equals to minus 1 by sine x into, if we simplify it will be cos of x by sine of x. Now this will be equals to minus 1 by sine x can be written as cosec x, and cos x by sine x can be written as cot x. Therefore d dx of cosec x equals to minus cosec x into cot x. Next, d dx of cot x equals to minus cosec square x. My function is cot x. Let y equals to cot x. Therefore y plus delta y will be equals to cot of x plus delta x. Subtracting 1 from 2, we will have delta y equals to cot of x plus delta x minus cot of x, implies delta y equals to, cot can be written as cos by sine, so it will be cos by sine minus cos x by sine x. This implies delta y equals to, the LCM of denominator will be sine x into sine of x plus delta x, and in numerator we will have sine x into cos x plus delta x minus cos x into sine x plus delta x. So this implies delta y equals to, Now in numerator you can see this is in the form of sine A cos B minus cos A sine B. So that can be written as sine of A minus B. So it will be sine of A minus B whole divided by sine of x into sine of x plus delta x. Let us divide both sides by del x also. So it will be del y over del x equals to sine of x minus del x whole divided by sine x into sine of x plus delta x, and since we were dividing both sides by delta x, so here also delta x comes. Here numerator minus x and plus x get cancelled, so we'll have delta y by delta x equals to sine of minus delta x whole divided by sine x sine of x plus delta x into delta x. This implies delta y by delta x equals to, see, sine of minus theta is minus sine theta, so it will be minus sine delta x whole divided by sine x into sine x plus delta x into del x. Now let us put the limit both sides. Limit delta x tends to 0, delta y by delta x equals to, see here, this minus and sine x I will take out from the limit, so it will be minus 1 by sine x limit del x tends to 0. Let me write this sine delta x and delta x together, so it will be sine of delta x by delta x into, let us distribute the limit also, so it will be limit delta x tends to 0 1 by sine of x plus delta x. Okay, so the left hand side becomes dy by dx equals to minus 1 by sine x into, this portion is 1 by sine of x plus 0. So this implies dy by dx equals to minus 1 by sine x into 1 by sine x, and this implies dy over dx equals to minus, see, 1 by sine x into 1 by sine x is 1 by sine square x, and since sine x is the reciprocal of cosec x, so we can write minus cosec square x. Hence we have d dx of cot x equals to minus cosec square x.